What if everything you see, the stars, the Earth, even your own thoughts, are part of a massive, sophisticated illusion? The simulation hypothesis suggests just that. Our reality might be an elaborate digital simulation created by an advanced intelligence. It's an idea that has leapt from science fiction into scientific and philosophical debate, raising profound questions about the nature of existence. At first glance, it sounds absurd, something straight out of The Matrix. But when you look deeper, the lines between science and fiction begin to blur. The modern version of the idea was popularized by philosopher Nick Bostrom in the early 2000s. His argument is statistical, logical, and unsettling. Bostrom proposes that one of the following three statements must be true. 1. No civilization will ever reach a level of technological maturity capable of creating simulated realities. 2. If such civilizations do exist, they will not run a significant number of simulations of their evolutionary history. 3. We are almost certainly living in a simulation. Let that sink in. If future civilizations develop the computing power to simulate entire universes, complete with conscious beings, and if they choose to do so even once, then the number of simulated realities would far outweigh the number of real ones. Statistically, it becomes far more likely that we are in a simulation than not. But could a computer really simulate an entire universe? In principle, yes, especially if it's only simulating what we observe. Like in a video game, the environment doesn't render everything at once, only the parts the player is looking at. Similarly, our universe might only be rendered at high resolution where and when it's being observed. This could even explain some of the strangeness of quantum mechanics. In the double-slit experiment, particles behave differently when observed, as if the universe knows it's being watched. Some interpret this as evidence of a programmed reality that saves processing power by collapsing probabilities only when necessary. Even constants of nature, like the speed of light, Planck's constant, or the gravitational constant, could be seen as coding rules set by the simulation's creator. But who or what would create such a simulation? Possibilities range from post-human civilizations to hyper-advanced alien intelligences, entities millions or billions of years ahead of us. If we assume exponential technological growth, it's not hard to imagine a future where entire realities can be simulated down to the atom, or even below. Their reasons: scientific curiosity, historical reconstruction, entertainment, or even ethical research. Perhaps they simulate countless universes to see how intelligent life evolves. Maybe we're inside a university experiment in another dimension. Still, the simulation hypothesis raises objections. One of the biggest is the computational complexity involved. Could even an advanced civilization store and process the data for every particle, thought, and interaction in the universe? Proponents argue that it wouldn't need to, just as a video game doesn't need to simulate the entire world at once. The simulation could be cleverly optimized, using procedural generation and predictive algorithms. And quantum uncertainty might not be a bug, but a feature built into the system. Others challenge the hypothesis on philosophical grounds. Even if simulations are possible, that doesn't mean they're inevitable. Advanced civilizations might have no interest in running ancestor simulations, or ethical concerns might prevent them from creating sentient suffering. Moreover, the hypothesis is difficult to test. If we are inside a simulation, the simulator could manipulate any observation or result. Any evidence we find could be fake. Any breakthrough could be reset. This makes the idea scientifically untestable, and therefore, some argue, meaningless. Yet researchers are trying. Some physicists have proposed searching for underlying discretization in space, like pixels in a digital image. If the universe has a minimum length, such as the Planck length, and time interval, that might suggest a grid-like simulation. Others look at cosmic rays, hypothesizing that a simulated universe might show directional patterns or energy limits based on the computational lattice used to build it. And yet, the most compelling question may not be, are we in a simulation? But what difference does it make? If our universe behaves consistently, supports conscious experience, and follows discoverable rules, does it matter whether it's real or not? Does being simulated invalidate your emotions, your creativity, or your sense of wonder? Perhaps not. At Infinity Beyond, we see the simulation hypothesis as a powerful lens for exploring what reality truly is. Whether we're carbon-based life forms in a cosmic expanse or lines of code in an ultra-intelligent program, our experiences still matter. The questions we ask still have value, and perhaps the very act of wondering whether we're in a simulation is what makes us real, simulated or not. In our next episode, we'll return to something more measurable, exploring the fine-tuned laws of nature that make life possible. Are the constants of the universe designed, or a lucky accident? Subscribe now to Infinity Beyond, and let's keep questioning everything, even the nature of reality itself.